So now that we've talked about the two different hypotheses, let me come back to the underlying theory and be a little more detailed about it and how it relates to those two hypotheses. So first thing is that some sort of claim is made about the population. And so based on that claim, you set up both your null and your alternative hypotheses. Now the null is the one that actually gets compared to the sample. So based on your null hypothesis, if it were true, how likely would it be that the sample happened? And then if that probability comes out likely enough, then okay, the null hypothesis could be true. But if it comes out very unlikely, then the null is probably not true and we reject it. And then based on that, we will make some decisions about the alternative. But for now, just keep that in mind. We either reject the null or we fail to reject the null based on the probability that is calculated. And we will talk about how to actually calculate that probability later in the chapter. For now, we'll just have those probabilities given. An important question is, how likely is likely enough to keep it as a possibility? How small does the probability have to be to actually rule it out? And as you probably know from previous chapters, 5% is a common cutoff, but sometimes for a particular study we might want to set the cutoff at a different level. So this is called the level of significance, and it will be given to you in these problems. So if it's not 5%, I'll tell you that it's something different. And then the probability itself is called a p-value. So once you have your hypothesis set up and you calculate this probability, we'll talk about how to do that later, that's called a p-value. So let's talk a little bit more about how the decision will actually be made. So you'll calculate this probability and then you'll compare it to the level of significance. So let's say I've said 5% is the cutoff for unlikely. So if the probability is less than that, then we'll reject the null, because that probability is telling me how likely the sample is if the null is true. So if the chance is very small, then I'm rejecting the null. Now remember, these two are opposites. So if I reject the null, I support the alternative. If the p-value is a little bit higher, then maybe I can't reject the null because it's not rare enough. So then I would fail to reject the null, which means I would not be able to support the alternative hypothesis as its opposite. This will probably make a little more sense when we actually have a case to be talking about, so I'll come back to this with some actual examples. After you decide whether you're rejecting the null or not, then you write up a final conclusion, and I'm pretty specific on the phrasing on these, and it all depends on that p-value and what you decided about the hypotheses. So first of all, let's say that the probability with the p-value was small enough for you to reject the null hypothesis. Then that probability was small enough, you were pretty sure there was sufficient evidence to reject that null hypothesis, and that's the phrasing that we'll use. That means that there's also sufficient evidence to support the alternative. Now you need to look at which one was the actual claim and talk about that one. So if the claim was the null, then you'll say there's sufficient evidence to reject the claim that blah blah blah. If the claim was the alternative, then you'll say there's sufficient evidence to support the claim that blah blah blah. Now on the other hand, if the probability is not small enough to reject the null, then we're saying that we're not able to reject it, but we're not really sure that it's true either, so we don't say that we're supporting the null. Let's say that your probability comes out to 10%. Well, that's not small enough to rule it out as a possibility completely, but 10% wouldn't really be strong enough to be so sure about it either. So that's why we use this funny fail to reject phrasing. We never ever support the null hypothesis. You're never sure about it. It's such an exact particular value that it's very difficult to be sure of it. So if the probability is not the p-value, if it is not small enough to reject, then we fail to reject, or we do not reject the null hypothesis, which means we are not able to support the alternative, which is the opposite. And then again, you pick which one of those your claim actually talked about and then write out the one that talks about that. So if your claim was the null, there's not sufficient evidence to reject the claim. If your claim was the alternative, then there's not sufficient evidence to support it. Some people find this flow chart helpful to keep track of all of this. So pretty much you start by saying, what was the actual claim in the problem before you even wrote down your hypotheses? Did that claim end up going into the null, or did it end up going into the alternative? So if it's the null, then we say yes. Okay, so it's the null. Did I reject the null? If I did, then I have sufficient evidence to reject the claim. If I did not, then there's not sufficient evidence to reject the claim. Now, on the other hand, if my claim was not in the null, if it was the alternative, then if I rejected the null, I say there's sufficient evidence to support, and if I did not, then there's not sufficient evidence to support. So notice that when your claim is the null, you're always talking about rejecting or not rejecting, and if your claim is the alternative, if it's H1, then you're always talking about supporting or failing not supporting. And then just to reiterate and emphasize this, failing to reject is not the same as supporting. So we do say fail to reject, we do not say support. And on the flip side, when you're talking about the alternative, we can fail to support, which does not mean that you reject the alternative. So when you're talking about the null hypothesis, you can only reject or fail to reject. You cannot support a null. And in the same vein, if you're talking about the alternative, you can support or fail to support, but you can never actually reject an alternative. And this can really throw some people off, so I just want to say a little bit more about it. Failing to reject doesn't mean that we supported it, just means that we didn't have clear evidence to reject it. So it could be true. We're not sure that it's true. We're not even close to sure that it's true necessarily, but it could be. So failing to reject the null means that the null could be true. And then failing to support the alternative means we didn't have conclusive evidence to support it. It doesn't mean that we were able to prove that it was false. So we're failing to support it. It could be false, but we're not sure. So let's look at some actual examples to see how this would work. So let's say that the claim is that the proportion of adults who shop using the internet is greater than 50%. Well, the first thing that you always need to do is identify the null and alternative hypotheses. So we're going to do that first, and then we're going to look at what would our conclusion look like if the p-value told us to reject the null, and then what if the p-value told us not to reject the null. And so we'll look at the two different ways that those conclusions would be phrased. So first we get our hypotheses set up. The claim is that the proportion, so it'll be a p, is greater than 50%. So greater than goes in the alternative. It goes in H1. So p is greater than 0.5. And then the null hypothesis, H0, is always the same number with an equal sign. Okay, so let's say that you run the calculations on this and the p-value, which would be the probability, is very, very small that the null hypothesis is true. Well, then that means we're going to have to reject the null hypothesis. So what would the conclusion sound like then? Well, what you have to keep in mind is that if you reject the null, that means you're supporting the alternative. And the alternative in this case is what the claim actually was. It was the greater than. So I really want to talk about the alternative when I make my final conclusion. So I'm going to say, all right, I rejected the null. I supported the alternative. I had pretty clear evidence. It was small enough to pretty conclusively rule out the null. So I do have sufficient evidence to support my claim. I have sufficient evidence to reject the null and to support the alternative, which is my claim. So the final write-up would say that there's sufficient evidence to support the claim that the proportion of all adults who shop using the internet is greater than 50%. And I threw that all in because keep in mind that we're using information from a sample, but you're drawing conclusions about the whole population, and so I need to see that you understand that. There are some key phrases in here that I need to see in your conclusions. I need to see whether there's sufficient evidence or not, and then I need to see what it is that the claim was that you're talking about. You can say to support the claim, you can say to conclude that the proportion of all adults. You can phrase that, use a couple different phrases for that, but you do need to have that there is sufficient evidence that whatever the claim was. Now, what if instead of having a very, very small p-value, we had a larger one, maybe 10% or 15%, not small enough to say that the null hypothesis is unlikely? Well, then we would have to fail to reject the null. If you're failing to reject the null, that means you are not able to support the alternative. And remember, the alternative was the claim on this one. So in this case, I have to say this one's a little more wishy-washy. I cannot conclusively reject the null and support the alternative. I'm not really sure. So that means there is not sufficient evidence. So when you fail to reject the null, that means you fail to support the alternative, and then that also means that there is not sufficient evidence. So then I can say either to support the claim or to conclude that the proportion of all adults who shop using the internet is greater than 50%. So those are the two different conclusions that you might come up with on this problem. It all depends on the p-value, and we will talk about those p-values quite a lot more in the coming sections and actually talk about where they come from. Okay, so let's try another one. An attorney at the FDA sues a pharmaceutical company. The company claims that their product does contain amounts of acetaminophen with a mean equal to 650 milligrams. So their claim is that the mean equals 650. So we're going to do the hypotheses and then talk about the two different ways that the conclusion could turn out depending on the p-value that gets calculated. So maybe pause here and try that, and then I'll give you the answer. So in this case, the claim is actually in the null. It's that the mean, so I'm going to use the mu symbol, equals 650. We're not really told whether the alternative should be greater than or less than, so we're going to make it not equal. So that's what the hypotheses are going to look like. Okay, so if we end up with a small p-value that makes us reject the null, that means we'll support the alternative. But actually we don't care about the alternative in this one because the claim was actually the equal case. So I'm actually going to talk about H0, which means my conclusions end up being phrased a little differently, so be really careful with this one. The claim is in the null, and that's the one I rejected, so I'm going to go ahead and say that we're rejecting the claim. There is sufficient evidence. There's always sufficient evidence if you're rejecting the null or supporting the alternative. Sufficient evidence to reject the claim that the mean amount in all of the caplets is 650. And then if the p-value is larger and we were not able to reject the null, then that's the not sufficient evidence case. But then whether you say support or reject, again, depends on which hypothesis you're actually talking about. And in this case, we're interested in the null again. So I'm going to say there's not sufficient evidence to reject the claim that it's equal. Okay, so because I'm talking about the null claim, that's why I'm using that word reject. I'm either rejecting or not rejecting. I can't actually support a claim that has an equal sign. So this often drives people crazy because I keep talking about this p-value that isn't there yet, but we will talk about it in the rest of the chapter. It's programs in the calculator. They sort of correlate to the confidence interval programs that we did in the last chapter. So we will come back to that. So far in this section, I'll tell you whether the p-value comes out to reject the null or not, and then you'll come up with the conclusion based on that. And then in the next section, we will build on that and actually have p-values to look at. So be patient on that.